Hi, my name is Rushil Cassetti. This presentation will be on the lessons my team learned while building a search engine. First, I'll briefly cover the goals of our project and a little background about how a search engine works. Then, I'll spend some time talking about what we learned when implementing the project. My team of 6 wanted to build a search engine that, when presented with a query, would return relevant web pages. To do so, we needed to crawl the web, downloading documents and indexing them so we knew which words were on each page. Our goal was to have approximately 100 million documents in our corpus. Now, search engines are composed of several different parts. On the left, you can see the index building side, which indexes the documents we crawl and stores them into an inverted index data structure. After crawling is completed, this structure is passed on to the query serving side, which takes in queries and searches the index for pages that match. Before we started building the engine, our team met and spent quite a long time planning how to divide the work and when parts should be done. Our team chose to divide into sub-teams to tackle each part of the engine. My sub-team worked on the index, specifically the index build component and the index stream readers, which allow other parts of the engine to get data out of the index. Right now, the crawler is running and collecting documents. It seems on pace to reach our goal number of documents. In the next few days, our team will finish up the query serving side of the engine, and we should have a fully functional search engine. When building the engine, our team learned several important lessons. The first was that failing to follow subtask deadlines ends up delaying the whole project. The second was that mistaken assumptions lead to confusing results. This came up when we were testing our indexer on some files and we were getting enormous chunk sizes. The third lesson we learned was that not considering how a tool will be used leads to last-minute interface changes. This came up when we were building our index stream readers. We had planned to finish indexing and crawling early, ideally by April 7th. This meant that we would have a few weeks to crawl the web and index documents. After that, we would have ample time to finish the query serving side of our engine and test each part. However, building the indexer was more time-consuming than we initially expected. We started a little bit late, which didn't help either. By the time we finished the indexer, we were almost a week late, which prevented us from beginning crawling as early as we wanted to. Since my team was also assigned the index stream readers, we started work on those very late too. This meant that the ranker, which uses the index stream readers, couldn't begin work until much later than planned. We were lucky that failing to follow our deadlines didn't do more damage than it did. In the future, we would like to stick to our deadlines so that we don't run into this again. The next thing we learned was that mistaken assumptions lead to confusing results. We expected that each index chunk would be approximately 400 megabytes, with about 20,000 documents indexed per chunk. However, when we started testing our indexer, we realized that while the number of documents per chunk was correct, the chunks themselves ended up being way bigger than anticipated, over 6 gigabytes. We first tried reducing the amount of overhead per word by setting a threshold value, so that we only used extra storage to speed up index searches when necessary. This helped, but not as much as we were hoping for. We then did some digging, and we realized that we had been indexing zip files and PDF files as well as regular HTML files. Since these types of files have lots of text in them that aren't words, our index chunks were having a huge amount of overhead. We told the crawler team what was happening, and they said they would fix the crawler filter so that it would only give us HTML pages. With these fixes, we were able to greatly reduce our size per document. We went from 6 GB chunks, each with 20,000 documents worth of information, to 400 MB chunks with 100,000 documents worth of information, which was even better than we had initially hoped for. The last lesson we learned was that not considering how other team members would use our index stream readers would lead to last-minute interface changes. When implementing the index stream readers, we only did the parts that we were specifically assigned to do. We didn't look into exactly how the ranker would be using the stream readers that we built. We found out that they actually needed a function that changed the stream readers into a format that helps with ranking. We had to rush at the last minute to add this in. We could have avoided this with more communication with the subteam that used our tools, which is the ranking subteam. Currently, our engine is still crawling. The next thing we have to do is finish up the query serving side of our engine, specifically the ranker. After that is done, we should have a fully functional search engine almost ready to present.